I practice just down the road in North Nibley with my partner. We've both been architects for a few decades, working in the Southwest and London in sort of slightly different fields. In the pandemic, we decided to sort of join forces, if you like, and do what we really wanted to do, which was slightly different from what we were doing at the time. Another big part of my life is teaching. I teach at UWE in Bristol in the architecture department, teaching design studio and also teaching the conservation module and retrofit elements of that. And that's a really exciting sort of place for me, really, to be part of the future of my profession and hang out with the youngsters. It's good fun. We decided to form our little practice because we really we'd sort of spent our careers working around sustainable design, around low energy design and that kind of thing, and conservation and other aspects. And it was the kind of recognition that working with existing buildings is really important in terms of where we are at the moment. And it was where we thought we could make quite a lot of impact. This, for example, is one of our most recent homes that we're completing. This is what we call a retrofit by stealth project, a little bit tongue-in-cheek. So, we have clients who come to us who don't necessarily know that they want retrofit until we talk about retrofit with them, and then they think, yeah, actually, I do want my whopping great extension, but also I'm going to do some energy improvements. So that's a sort of big part of the work that we do, is working with people to help them understand how they can also improve the energy efficiency of their existing homes. So, as I say, we're very conscious of the impact of buildings in the built environment. This is a bit of a confusing graphic, but I'm just going to talk a little bit about the national picture and the carbon case, if you like, for retrofit. Well, amongst everything else, we do have an agreement, the Paris Agreement, that we signed in 2015 to reach net zero by 2050. So that is our national target to do that. It is right that we are trying to work out how we're achieving that. So you can see here our total UK emissions, greenhouse gas emissions. Up there, probably can't read all the little bits and bobs, but the colours are referring to, the donut at the top is referring to different sectors that the Climate Change Committee have identified. So when we look at the built environment, we can see that that's really quite a large chunk. It's actually about 42% of our total emissions are in the built environment, so that's an enormous amount. That's including building our buildings, operating our buildings, running them, if you like, energy from all our plug loads and all our appliances, and also our direct transport emissions. When we take off those other things and look just at the carbon load from our buildings, we can see that's more akin to 25% of our total UK emissions. So it's still quite a large proportion. Buildings are inherently unsustainable at the moment and always have been. Well, sorry, haven't always been, but have been for quite a significant period of time now. So we can then sort of split things down further, and that bottom donut there is beginning to differentiate between our operational carbon, so the carbon that our buildings use. The dark blue is the domestic buildings, or the darker blue, and the lighter blue there are our commercial buildings. And then the gold bands, they're referring to our embodied energy, so the energy it takes to build our buildings. So that's the picture there. Our embodied energy at the moment is about 25% of that 25%, which means 75%, the majority, is the operational carbon. So why do we need to retrofit? Well, obviously we need to retrofit. 80% of the buildings that we're going to be operating in 2050 have already been built. So a major priority is decarbonising our existing stock. If we're going to get to zero carbon by 2050, or sooner, hopefully, then we absolutely need to focus really heavily on this. Also, 20% of our housing stock was built before 1919, and that's quite unique in Europe. We've got the highest proportion of older buildings, traditional construction buildings in Europe. And we've got the accolade of being the least energy efficient in terms of our building stock as well. So we've got a lot of work to do. We need a strategy. We desperately need a strategy. We're brilliant at writing strategies in the UK. The Green Building Council have a fantastic strategy that they've written out about how we achieve this. The Construction Industry Council have one. The Construction Leadership Council have one. Arab have one. More or less everyone has a strategy about how to achieve a retrofit programme for the UK to bring our buildings into check. You know, and you hear these statistics that come out every now and again. 1.5 buildings a minute need to be retrofitted if we're going to meet our 2050 targets, all these sorts of things. So the challenge is very real, and the approach that that people have worked out is possible. You know, we need a programme that will improve energy efficiency and upgrade 29 million homes, the Green Building Council say, across the country, starting with the 19 million that are currently EPC rated D. Okay. So when none of these strategies have been adopted into government, when we see it how we're doing, this is another Green Building Council graphic here, which shows our progress over the last from 1990. This was published in 2021, I think, and it's taking us up to 2018 emission carbon budget. So we can see here we have made some progress since 1990. It's been slightly rocky road. Again, you can see there the blue is the operational carbon and the gold is the embodied carbon. So we've since 2008 we have reduced by about 30% our building energy, which is all right, you may think. And there was quite a lot of investment in 2010, 2013. We had various rollout schemes, lots of energy obligation, company obligation schemes that went into fruition, and we made some inroad into reducing our carbon emissions in the domestic market, certainly. However, since then, we have really done very, very little. We've divested from that enormously. And in fact, now the improvements we're seeing are more due to the fact that we've decarbonised our electricity grid. So that's why we're improving, or have improved during those years. So really, we're not doing quite as well as we should be by any stretch of the imagination. And at the moment, we're pretty much all at sea. Building energy is still a significant part. So the Green Building Council's roadmap that they've published, I've sort of squished and pushed in there to show you at the same scale what we need to do to carry on to get to zero carbon by 2050, and it is quite a phenomenal task we've got ahead of ourselves. So some of the sort of strategy measures that the Green Building Council are talking about are things like ending the sale of gas boilers by 2030. Now we know that that's been recently pushed back as a target. Also, and this one is much more of a challenge for us, by 2028, a mandatory minimum EPC-C, so that's the energy rating of your home. You'd need to be able to prove that your house was at that level of energy efficiency at point of sale for owner-occupied homes and in the domestic rented sector. So some really quite stringent requirements if we are going to manage to decarbonise at this scale. I think that would be an enormous challenge for us to turn things around and consider our responsibility as homeowners as being something that we had to take really seriously and retrofit our homes to that extent in that time frame. So an enormous societal mental shift is needed if we're going to do this. So, it's little wonder, isn't it, really, that our government keeps watering down its commitments. So this is September. There was a big announcement that the government was going to abandon a lot of its policies around this. So, for example, we were just on the cusp of bringing in this idea that private landlords needed to get their rental properties to EPC-C. That's now been scrapped, and the gas boiler ban pushed back to 2035. The way I see it is, there was a lot of kind of talking around this, that people can't afford to do these measures at the moment. But the way I see it is that the government is actually saying it's not our problem. We're not the problem here. It's not our territory. But I feel it's our collective problem, absolutely. And it's something that we really, really need to invest in and work out how we're going to manage to do this. Similarly, in February, same thing happened. So, it's basically a political hot potato to say that you're going to spend £28 billion per year on net zero. And this sentiment is across the political spectrum and is a big problem if we want to have a planet to live on. We have to be able to commit in this way. But in case we needed more reasons to commit to retrofit, there's another kind of side to this that I think we need to be really conscious of and aware of. The whole retrofit mantra is not just about environmental sustainability. This is the latest Climate Change Committee report. It was issued in 2023. It's called Progress in Reducing Emissions. And it was the report that was given to Parliament at the time. So figure 1, highest priorities for further adaptation. So this is looking at the ways that we need to, our high risk aspects that the government is facing in the decisions it's making at the moment. And this is not just about reducing emissions, but it's also in adapting to climate change. And it's pretty gloomy viewing, I'm afraid. There's lots of very urgent, high priority, high risk items on this list. Things like risks to biodiversity, soil health, food security, economic failure, that kind of, fun thing to deal with. Number 8 on the list of our top priorities, or 7 rather, East, risk of overheating. So risk to human health, well-being and productivity from increased exposure to heat in our homes. So there it is. Retrofit is not just an environmental sustainability issue. It is also absolutely intrinsically linked to health equity and the health of our nation, because our buildings are now becoming a risk to us, because we know that poor buildings are really bad for our health. And this report is picking up the fact that our climate is going to change, and our buildings are really woefully ill-equipped for dealing with the high heat stresses that we're going to experience as we go through the century. So we're already seeing this happening. We're already seeing the impacts of our really poor housing, and we have done for a long time. And we sort of ask ourselves the question, how can we afford not to improve our housing stock? So when we look at the figures for fuel poverty, we can see that the most vulnerable in society are most critically affected by poor housing. The exorbitant energy bills, poor health, poor well-being, physical issues such as respiratory problems from damp homes, people being unable to put the heating on and having to choose between heating and cooking. So yes, particularly prevalent was the very tragic story of Awab Ishaq in Rochdale, the 2-year-old who died, and it was proved that this was because of exposure to damp and mould in his home. So we've got really big societal issues by not taking the quality and the performance and the comfort of our housing stock seriously. We know that elderly people are vulnerable to poor housing for multiple reasons. For example, income pretty much doesn't fluctuate. With pension income generally doesn't fluctuate but stays very steady, but costs of living change. Elderly people may be less mobile. They may also be in their houses for longer periods of time. So we know that they're very much at risk of fuel poverty. But actually statistics show that this is not an elderly problem. This is a problem across society. Anyone who has an unstable income or a low income or a single income or is benefit reliant is in a very jeopardised position in terms of fuel poverty. We also see rural poor, so people who are not on the grid, people who are plugging into gas bottles that are very expensive, that kind of thing. have poor access to infrastructure, support infrastructure, libraries, cafes, that kind of thing as well. And then also the young, so 16 to 25-year-olds are a real issue with fuel poverty. Lots of them are in private tenanted properties that are very poorly looked after and don't have enormous income. So there's a real problem with fuel poverty with the young as well. And I think these pie charts here on the left kind of illustrate that. So they show the one on the very left, the percentage of households, shows us that the largest percentage of households are owner-occupier households, and then it's kind of a vaguely even split between social rented and private rented. But then when you look at the proportion of fuel-poor households, you'll see that there's a much larger proportion there of the private tenanted properties. People in those properties are suffering from fuel poverty. So I also put in that little affordability measures graph there. So the government, for a long time, maintained that fuel poverty was going down. And they kept that up for quite a long time, but they were called out so many times that in the end they had to drop it. But they kept putting this graph up. And this goes up to 2022, which shows you how quite recent it is. So they were measuring fuel poverty using this scale called LILI, which stands for low income, low energy efficiency. So they were mapping a home with poor energy efficiency with someone with low income and completely ignoring the cost of fuel. So that's how they managed to maintain that for that length of time. The other graphs you can see kick up quite considerably in the last few years since the pandemic, taking us up to 30%. And so that line there is above 10% costs after housing costs of income. This is thinking about how much money people have left after they've paid for their fuel bill, basically. And if they're in poverty at that moment and also in a low energy efficiency house, then that's the measure for fuel poverty. So, sorry this is a bit gloomy. We'll get on to lighter topics in a minute. So, there's an enormous cost to society of us ignoring this problem. This statistic comes up, but it's a sort of catchy phrase of common illnesses caused by cold homes currently cost the NHS up to 1.4 billion. I keep coming across that every year. But that's not actually true anymore. There's been a new report come out in February of this year from the Institute of Health Equality that states it this way. They say tens of billions of pounds a year in costs to the NHS and lost productivity, so don't break it down, would be saved by investing 6 billion annually in a national insulation programme. So they're saying that we're running a very leaky ship by ignoring this problem, by the associated societal costs of health and lost productivity, or people out of work, basically. So that report is called Left Out in the Cold, The Hidden Health Costs of Cold Homes. Pretty gruelling reading, really. It's Professor Sir Michael Marmot, who did the Marmot report about, I don't know how many years ago, probably 2010, 11, that sort of time. And so this is his next report on, and he's really cross. He says this is a national scandal. He says, so he's sort of statistics like the one I just said, and 9.6 million households are living in heat-leaking, poorly insulated homes. That does equate to about a third, which correlates with the government figures on fuel poverty. Fuel poverty leads to impossible choices between healthy eating and a warm environment. And then the links with mental health are pulled out of this report. Cold homes double the risk of adults developing new mental health conditions, and also put a quarter of children at risk of multiple mental health symptoms. So cold homes are really bad for our mental health as well as our physical health. And he says that he thinks poverty should be a national scandal. And the tragedy is that this is all entirely remediable. So very much drawing the link between poor housing and health. Also the intersectionality around that of age, gender, race. Minoritised ethnic communities are more likely to live in poor housing that's a proved fact, and I've seen the government break down statistics as well as in their reports. So there are all kinds of aspects to this that make it seem an extremely pressing situation. Okay, so the government has done some things over the last few years. Part of the hiatus, part of the reasons why retrofit has been so difficult to implement is that it's quite difficult. And I mentioned that we've made some progress between 2010 and 2013. The rest of that decade was epitomised by some really poor examples of mass retrofit that was very badly managed and went very wrong and put people in really even worse homes, actually, than they've been in originally. So at that point, the industry realised we needed to upskill, we needed to understand what we were doing better. Okay, so we're now kind of starting to gear up a little bit, and there have been waves of funding coming through. And most of this has been directed at the social rental sector. I guess because perhaps it's easier to manage. You can deal with a social housing authority and manage retrofit in a larger scale than dealing with individual householders. So it's slightly simpler to manage. So there's something called the Social Housing Decarbonisation Fund. So just under 4 billion has been invested to cover 5 years, so not quite what Marmot was hoping for. He was saying, I think, 6 billion per year. My practice has been involved in this as well. This is so there's some photos of the retrofit going on in Cheltenham. So we've been doing retrofit for Cheltenham Borough Homes via this scheme. So we did about 60 homes in Hester's Way, and you can see there on the left the house beforehand. Solid concrete construction, so quite challenging to retrofit. The sort of building physics of it has been quite interesting, and let me tell you, it's not glamorous. So that's where the joy is, really, I'm afraid, in working out where the condensation's going to be. But Jim was shortlisted for the Retrofit Designer of the Year award on the back of this, so there has been some pleasure from it. So that's been happening. There has been some movement in the social renter sector, and that continues. And I think another wave is coming soon. So hurrah for that. In the private tenant and owner-occupier sector, there is also some funding out there. So 12 billion has been put forward in help to heat schemes. So we're looking at energy company obligation schemes that's still running, a few of them. There's something called Eco Hug. And various other schemes. Most of them are focused around sort of a single measure. So you get funding to do insulation, or you get funding to do your new windows or your air source heat pump or something like that. Although with Eco Hug, actually, that one is trying to engender this idea of a whole house approach. So you get funding to do measures that are appropriate rather than specific measures. But that phone number there, the advice line for Warm and Well, that is a really good service that we should all sort of spread the word about, really. There is energy advice, and it's specifically for Gloucester and South Gloucestershire. They will basically help you work out whether you're eligible for funding. It's quite difficult to get funding on these things. You've got to have a low enough income to be eligible, but then you've also got to have some money put away, because ultimately you've got to contribute to the cost as well up front. So finding that sweet spot is really quite difficult. It's not very comprehensive, basically, way of getting retrofit out there. It's a bit piecemeal, and it's not quite where we need to be, but it does exist. Okay, yeah, so we have, potentially in this room, some people have got some agency around thinking that they might be able to do something all here, which is fantastic. So obviously kind of have an interest, which is brilliant. So I thought I'd just talk through a little bit about how you might think about approaching a retrofit project in your home, potentially, and talk about a few aspects around the things that you kind of maybe need to be aware of. We've talked a bit about funding. So at the moment, unless you're in a position where you fit into a kind of funding bracket, you're probably going to be self-funding this. So it's about, I guess, thinking about your budget. So it's thinking about whether your budget is a big budget or a little budget. It's possible, so thinking about how this might be something that fits with other work you're doing in your house. So you might think, right, my kitchen is really rubbish and I've been wanting to sort that out for a long time. What might I also do in that element of my house? I might perhaps increase the insulation. Perhaps the floor's really cold all the time. This might be an opportunity to put some floor insulation in while I'm doing this work. So that might be a way of kind of thinking about how you can bring retrofit into your house, into your work. Or we have clients who come to us and say, I want retrofit, and we love those clients. They're brilliant, because then we can really get stuck in and do really lovely, thoughtful work about how we do this and think about it globally. So absolutely, that's a way of doing retrofit too, is to do retrofit for the sake of retrofit. You're going to have to kind of upskill and understand things about retrofit and get knowledge and get advice. And we're already kind of identifying that we've got real gaps in that process here. But more on that in a bit. You might need design advice. So you might need a professional. You might need a retrofit assessor. You might need an architect or a designer of some description, especially if you're thinking of doing other parts of your work. You're going to need some kind of a plan. You're going to need to sort of decide what you're doing, and that might be something that unravels over time. It might be that you're not doing everything all at once. This might be a long-term project. You're going to need some builders, unless you're a DIYer. But if you do need builders, you're going to have to know that they're competent at doing this, because it's not always straightforward. You might have questions around things like planning permission and other kind of permissions. Maybe you're in a listed building consent is quite an issue. You might also need the cooperation of your neighbours. You might live in a semi-detached house, you might live in a terrace, and things that you're thinking about might impact others, and that is basically an opportunity really, isn't it? So there are some key terms around retrofit, which I'm just going to kind of bring to you here. The first one is this term, fabric first. So certainly in my world, we think about retrofit in terms of using the building fabric to reduce the energy demand as much as possible. And then after that, we think about systems, as in heating systems, most typically in the domestic sector. So by reducing the energy demand of our building, that means our systems can be suited to match that reduced demand. If we upgrade our systems first and then think about the fabric, we've missed a trick. We've put in a system that's too high capacity. Fabric first also means thinking about the fabric of your existing house and getting that retrofit ready. And I'll talk a little bit more about that in a minute. We've got all these catchphrases in retrofit. Retrofit ready is one of them. Then we've got this idea of whole house retrofit. So people talk about whole house retrofit and elemental retrofit. And most retrofit, to be fair, is done on a kind of measures basis. So unless you do all your house in one go, where you might consider it, in one entirety, it might be that you're doing measures bit by bit. However, if you're doing it in that way, you're perhaps insulating this one year and doing that the next year, you still need to consider the whole very carefully, and you need to plan in a kind of long-term way. Because, as I pointed out before, sometimes it's worth doing certain things before other things. And also making sure that you're not causing problems by doing something before another thing. Sorry, this is all sounding very complicated. A whole house is also referring to this idea of being very careful about how elements come together and the junctions of things, because that's where problems can occur. And then we also talk about risk in retrofit, which I've kind of alluded to, and the knowledge really that if it's done wrong, it can cause more problems than you had in the first place. And that generally, the risk is generally around moisture. So it's generally about moisture getting trapped in the building or creating areas of the building where condensation can form, that kind of thing. Creating areas in the building where you're putting a lot of thermal pressure. You've got perhaps more insulation in one area than there was before, and so you're creating a small bit of the building where there's an awful lot of heat trying to get out, called a thermal bridge. So areas like that are where the risk is, and it's always generally in the junctions between things. And then on top of all that, if you've got a traditional building or a heritage building, you've also got the challenge of trying to make significant or wholesale improvements to your building whilst retaining its quality, its character, and its special interest. So by traditional construction, I'm talking about solid stone walls. That's sort of pre-1919 construction, and solid stone construction. And then by heritage, I'm basically meaning anything that's got a designated listing to it. Also, sometimes things in conservation areas might have implications around the things that you can do. Wootton's a conservation area, isn't it? Centre of Wootton, presumably. Yeah. Okay, so I'm just going to run through a kind of process of how you might approach it if you were going to try and sort of think about your own retrofit project. So the first thing you need to do is really think very carefully about your building. You need to kind of assess it, if you like, and a retrofit assessor might do this role for you and with you. You need to know what construction type you've got. What's your building made of? Has it got cavity? How much insulation has it got? What's structural? What's infill? That kind of thing. What sort of condition is it in? Does it need a lot of repair? Is there an opportunity in that to do repair and retrofit at the same time? Does the repair need to come first? The location and orientation is important. Is it really exposed, your building? Is it facing that southwest trajectory? Is it on a north-facing slope? Does it get a lot of sun? Is it in a frost pocket? All these things impact how your building performs in a kind of building physics way. And then also the region and the microclimates. And, we know that these might be subject to change with our changing climate. We already know that we're getting more rain and all these things, potentially more subsidence. Then you might look at the fact that most buildings weren't built in one go. A lot of them have got extensions or adaptations. Are they all of the same quality? Are some bits worse than others? Some bits more colder, or less well constructed? Are they sacrificial? Should you just get rid of them? Or should they be the areas that you target first? Areas of thermal weakness. How airtight is your building? Now, that's a word that kind of jars slightly. We like the idea of having fresh air in our homes. Our homes are incredibly leaky, most of them are. We have an enormous amount of uncontrolled infiltration in our homes that we're not really conscious of. And most of us are actually relying on those for ventilation without even realising it. Some of us have ventilation in our bathrooms, particularly in kitchens, but does it still work? Do people use it? Do people switch it off? And then all moisture issues around buildings, and any other sort of pathologies, any rot or aspects like that. And then you also need to think about how you use your building. What's your lifestyle like? Who lives in the house? Do you all go out to work? Or are you all there during the day? Do you like a hot house? Do you like a cold house? Are you very active, or are people quite sedentary? Also, what's your motivation? This is quite important. It might be that you're thinking, right, I'm going to retrofit my house. I'm going to get it in a good state. I want to get it up to EPCC. Maybe this is a kind of future-proofing. And it's not a house that you're thinking you're going to stay in forever. Or it could be that this is something you want to do so that your home is comfortable for you for the forthcoming decades. So that might affect how you do retrofit. And then very importantly, this idea of maintenance now. So the idea of maintenance being a really critical part of all this. And in fact, that sort of brings me on to my next point around fabric first. Sorry, there's so many words up there. I just wanted to show you that these two kind of key documents around retrofitting, one from the Institute of Historic building construction, and one, the British Standard on historic buildings. Both are really, really pushing this idea about maintenance, and I think they're right. The IHEBC goes as far as to say, first of all, before you even think about retrofit, get the original building fabric to perform as the best it can with appropriate maintenance and repair, as well as providing it with appropriate use. So with traditional buildings in particular, there's perhaps not that much you can do. Having a really well looked after building is actually really important. Having those gutters cleared out so that they're not overflowing and water's not getting in the fabric. Having clean windows gives you better light. All these little things. I mean, I shouldn't really be saying this because my maintenance regime is not brilliant. But this is a factor in retrofit, looking after what we've got. The British Standard there talks about not needing to replace things, avoiding unnecessary decay and the required carbon involved in that, embodied energy. So especially with historic buildings, maintenance and care is kind of considered very much the first step of being an energy efficient householder. Okay. Then we got this idea of being retrofit ready. So getting a house into a state that it's sort of ready to be retrofitted, or it's appropriate that it's retrofitted. So that really means basically if there are existing issues that they're addressed before or very much part of the retrofit process, that they're not ignored, they're not covered over. If retrofit over a damp problem, you're probably going to end up with a right nightmare. So think of those remedial measures. Think of the fact that a damp wall is going to be pulling heat out of your house anyway, so it absolutely needs to be addressed. Then, thinking around measures for upgrading homes, thinking about what approaches you're going to take in terms of which particular kind of measures are most appropriate. So thinking about heating. So how do you reduce the energy demand for heating? Well, it's through insulating, isn't it? And addressing that uncontrolled infiltration. It might also be around cooling. That's becoming more of a thing now. We don't need air conditioning in this country, and we won't need air conditioning in 50 years' time if we design things right. Air conditioning is a massive carbon load, enormous problem in cities with urban heat islands. So we need to use clever design instead of cooling using energy sources. And then also thinking about ventilation very much. So these are the kind of fabric ideas that we need to think about. So I'm just going to talk about a couple of examples of this. So this is a project, this is a listed building. It's a really beautiful double gable fronted farmhouse that was in a really, really poor state of disrepair. So my job in this was to bring it back into a good state of repair. And we also thought, right, this is an opportunity to do some energy efficiency improvements as well. So here's an example of working with a listed building. I don't know if anyone lives in a listed building who's here today or has these kind of concerns. Okay, yeah, some of you do, yeah. Okay, so the conservation officer here was absolutely adamant that the really beautiful ridgeline, which was very bowed, in fact, the whole thing was kind of on the verge of collapse, but that didn't bother the conservation officer. She wanted that beautiful shape maintained. So we had to address the structural issues. We had these two gables kind of falling in. That photo is not exaggerated, okay? It's true projection, that photo. So we've got these gables coming in because the roof is structurally on its way out, basically. But the conservation officer is telling us under no circumstances can we alter that line or raise it or do anything. So, it was good fun. And we sorted out the structure in a different way. I won't tell you about that now, as we really will be here all night. But we appreciated that we couldn't touch any of these timbers. They had to stay there. So we did some strengthening, basically. And then we're thinking, okay, how on earth are we going to improve the performance of this roof if we put insulation on top of that structure? Obviously, the ridge will go up. We can't do that. If we put insulation below that structure, we're going to put that roof, those timbers, in a risk situation from interstitial condensation. So we don't want to insulate underneath. So we suggested this product, this quilted insulation product, to the conservation officer. So this product is quite clever. It's a very new material and extremely modern. So there's a bit of conflict in the conservation officers. Is anyone a conservation officer here? Just checking. Mind about this, and it took a lot of justification. It works because it acts like a building felt. So if any rain gets through those beautiful tiles there, it will run down the top surface of that quilt. It has some thermal performance. And it also eliminates the risk of condensation because it's a breathable membrane. It's a breather membrane. And because it's squishy, it's like a quilt, every time a batten came along, it would push down. So it wasn't taking up any space. But then in between the battens, it would puff up and create some thermal resistance. So that is simply all we did to that roof. We put some replacement timbers in and some strengthening timbers, and then we laid this triple membrane quilt on top of it, and then replaced the tiles. But the process of justifying that to the conservation officer was lengthy and took a lot of meetings and a lot of demonstrations for them to have the faith in this product, really, that it wasn't going to cause any unintended consequences in the roof. So that's kind of one extreme. Then the other extreme is where we had similarly a solid stone construction cottage in this case that wasn't listed. That we were under no restriction in terms of listing, and also when we assessed the building, we didn't think there was any significance there, any sort of heritage significance. It's not all down to the conservation officer that we needed to maintain in the roof. So we were able to remove that roof and replace it with a new roof that was highly insulated, and we weren't restricted around ridge heights and all that kind of thing. So we had a lot more freedom. So with this building, we had a lot more capacity to do a really very heavily insulated, highly airtight, highly sophisticated retrofit job, where we were entirely controlling the thermal performance and also those infiltration moments. So this house has been completed to Passive House standards. There you can see the original cottage there on the left, quite a small cottage, and you can see it's had insulation on the outside. Again, the change in appearance has not been problematic. It was rendered anyway. The cottage has got a bit bigger because it's got insulation on the outside now. And then a new roof, new windows, all kinds of things, and a large extension as well. And you can see here that the new roof is going on with some new structure, and that's how the extension sort of abuts onto it. It's quite a large extension, as you can see. So that's the other kind of end of the spectrum, if you like, with traditional construction, from a very pared down conservation approach to all in, let's go for it kind of approach. That project I'm going to talk about in a lot more detail another time. Okay, so there's a lot to be said about that project, but I just wanted to show you two approaches. So this is just a couple of slides about shading and avoiding overheating in buildings. So this is basically about thinking about sun angle of your windows. So, part of retrofitting, we think that retrofitting is all about conserving heat, but actually a lot of our retrofitting needs to be about preventing overheating. And the key to that really is about preventing direct sun onto glazing in the summer. It really is as simple as that. And obviously providing opportunities for purging and air to move through buildings. If you can nail both of those things, then your home will be much cooler. Obviously, insulation and thermal performance of your walls is really important too. Okay, but the other two is the sun on windows is really critical. So this project here has worked really hard. It's got a lot of south-facing glazing, but it's worked really hard to ensure that the high summer sun is cut out and does not touch the glazing, and the low winter sun can get in. So when the sun is low at those times of the year, it will come into the windows and right back into the house and heat the house. But in the summer, it's prevented. And that's through just very simple external shading measures. So this one, for example, has got a balcony here, which is never used. It is purely just for shading the glazing underneath. And then there's a canopy on top, and that can come off in winter if it needs to. And then along here, there's another canopy. So there's a little diagram. So on the south face, that works really well. Obviously, on the west facing and east facing glazing, it's much more complex getting your shading right, because you've got that low sun in the winter and the summer. So it's not quite so simple. You're going to need to think about vertical louvers and that kind of thing, or adjustable shading, or blinds. Preferably, any shading that can be on the outside of the building is much more effective than shading on the inside, but as a last resort, closing the curtains, for example, will make quite a lot of difference. Also mentioned there, vegetative and evaporative cooling, really important toolkit there of using planting to reduce temperatures, and especially deciduous planting that obviously has its full leaf cover in the summer and allows more light and sun to hit buildings in the winter is a really useful tool. So allowing plants near buildings but not necessarily growing up them is a good idea. And obviously evaporative cooling. You know, there's so much that we can learn from vernacular and indigenous architecture in hot climates in our sort of palette of opportunities for keeping buildings cool. And you look to the Middle East, where you've got dry, arid conditions, you know, and the use of water that evaporates and takes heat away. So a courtyard with water in. Yeah. And then, of course, air movement is the other key one in terms of trying to keep buildings cool. And sometimes that might need to be assisted by some kind of mechanical action. So fans and things. And then once we've looked at the fabric, then we start thinking about the systems. So it might be an air source heat pump. It might be a new heating system when budget allows, when need allows. It might be a mechanical ventilation system, for example, some kind of continuous centralised ventilation. With retrofit, inevitably, we are, by adding insulation without even trying, we're going to reduce the infiltration through the walls. So if we're not really careful about ventilation, we're going to end up with problems in our homes because we'll be reducing the amount of ventilation. We produce so much water through breathing and, of course, all our cooking and washing and all those activities in our homes that they're really quite wet. And we have to be really careful that we allow that moisture to move out of our homes. Obviously, it's problematic because we don't want the heat to leave our homes at the same time. But we've got these clever bits of kit like what's called an MVHR, mechanical ventilation heat recovery system, that will continuously be providing fresh air and heating that fresh air from the stale air that it's expelling. So we've got kit that will do this and will run on very low energy costs. So our kind of aim, certainly in sustainable building design and also in retrofit, is to try and improve the air tightness of our homes so that we're controlling our ventilation really carefully, but at the same time making sure our ventilation is adequate, because that's absolutely key in avoiding problems, building physics problems, damp condensation issues. A few whole house issues here. So this idea of making sure that we're not creating problems through retrofit and thinking about how components interact. So just a little example here of perhaps putting some internal insulation on a building. Perhaps it's listed and you can't put anything on the outside, or you're in a conservation area, or you've got a really beautiful facade that you don't want to cover over with external insulation, you might consider internal insulation. It's not as effective as outside, but it still can do a really good job. So here, this is making the point, this third little diagram over here, that by taking the insulation down those window jambs, you're not ending up with a situation where you've got a cold bridge through this area. So you're connecting your thermal line throughout the building. So connecting the wall insulation with the thermal line of the window to prevent a cold spot. If you had a cold spot through there, you might end up with condensation and then black mould on your jambs. Yeah, so things like that, being really careful, making sure your systems are moisture open. We always advocate moisture open insulations that are allowing moisture to breathe out through them. So wood fibre systems, that kind of thing. And then again at foundation level, thinking about avoiding these areas where the cold can bridge through. So this is the best practice example here, where insulation is taken right down and also the floor is being insulated. So, as I say, thinking about the whole building and the interactions between components. So yeah, avoiding risks. Here we are. So this is just talking about the amount of water. There we are, 9 to 15 litres of water vapour per day in a typical 3-bedroom house. Okay, those are a couple of slides, not from my projects, I'd just like to say. Those are from Preston. So if anyone wants to read a retrofit horror story, look up Preston. That was one of the schemes that I think, set us back enormously 10 years ago because it was just so poor. Caused a lot of problems. Right. So I'm just going to highlight this bottom one here, your neighbours' cooperation, as a key element of this. So in communities, we've got an opportunity to do things in a different way and to think about retrofit in a kind of people-scaled way. So to sort of broaden out our definition of retrofit, it doesn't have to be about our own home and our own project. It can be something that we try and think about on a community level. And that's possibly our greatest opportunity, really, in terms of this. There are obvious advantages around upscaling knowledge and forming. I wanted to show you this. Where is it? This one. So I swear this is my only Google Pics image. And I sincerely hope all your neighbours are as glamorous as that lot. So this is Fairview and Oakley Retrofit Circle in Cheltenham, Honest. They're real, Fairview and Oakley Retrofit Circle. They've come together and they formed a retrofit circle whereby they have monthly training evenings where they come together and they learn about retrofit together, and they feed each other's kind of enthusiasms. Also, they're kind of taking it on a sort of street-by-street approach because they all live in the same types of houses in that area of Cheltenham. So their problems are the same problems. Their retrofit conundrums are the same as their neighbours. So it sort of makes sense to do it that way. Also, to think about retrofit beyond the home. As our climate changes, we're probably going to spend more time outside. So thinking about our local areas, how can we make little pop-up gardens, little vegetable plots? How can we sort of use our external spaces in a more communal way? That comes under my definition of retrofit. Guerrilla gardening, all those things that provides spaces for people to inhabit and spaces for people to be in and be together in that might be really nicely planted, and cool spaces out of homes that are respite from hot spaces. We've got things like energy co-ops happening in the UK. There are various companies like Big Solar Co-op that's offering energy co-ops. So they did a LiDAR imaging survey of Birmingham and found out that they could generate 1.6 gigawatts apparently off the roofs of Birmingham. All the roofs that they would rent out off the inhabitants, and this would provide something like 37% of the energy that Birmingham needs on a hot day. what could Wootton achieve in that regard if all the roofs were combined and there was a community energy project from there. Then we have actual retrofit schemes coming through. Again, sort of capitalising on the fact that the housing typology is similar. So streets coming together to do retrofit schemes and transform whole streets, and together able to access funding. So, for example, the Fairview and Oakley Retrofit Circle managed to get some funding from Cheltenham Borough Council to run their retrofit education programme. I think actually the whole thing's folded at the moment, fortunately. But the intention was there. They got the funding and they made a start in that. And you know, so who knows what can be achieved. There are various things. Birmingham's got a really big movement going on. There's lots of stuff going in Manchester, Oxford as well. So the cities are kind of waking up to this. There may well be smaller communities where this is happening as well. I'm sure there are. I just don't know about them. But there are endless possibilities. That's Bristol.